At a United States Air Force base, beneath a bright daytime sky, a massive silhouette slowly becomes the center of attention. With an impressive wingspan of more than 56 meters, 185 feet, the aircraft dominates the flight line. This is the B-52 Stratofortress, one of the most iconic strategic bombers in the history of military aviation. For more than 7 decades, the B-52 has served as a symbol of America's long-range strike capability. The aircraft has flown through multiple eras, from the Cold War to modern military operations. Although it is significantly older than many of today's combat aircraft, the B-52 remains in active service thanks to continuous modernization programs. Before this giant aircraft can take to the skies, however, a series of precise procedures must be completed. The entire process begins long before the pilots take their seats in the cockpit. On the ground, dozens of maintenance personnel have already spent hours ensuring that every component is in optimal condition. The initial inspection covers nearly every section of the aircraft. The fuselage, wings, landing gear, hydraulic systems, fuel lines, and engine compartments are all carefully examined. Every bolt, access panel, and structural connection is inspected because no detail is considered too small when flight safety is involved.
It's a computer that uses our AHRS, our Attitude Heading and Reference System, puts all that together, the brains of operation. And all these wires that come out of it go to different systems. They kind of communicate with a lot of different parts of the jet. But this one specifically right here, it goes down here to this right here, and that is a gyro reference unit. And it's a spinning disc, spins super fast, basically uses the inertia of it to kind of give you the gist of what the aircraft's doing and where it's heading.
Also shows some pitch command steering bars and some roll command steering bars that also help guide them with how they need to travel. This is our HSI, the horizontal situational indicator.
Control panel. This control panel is what our air crews use to turn autopilot on and off and control all of the functions of autopilot.
Meanwhile, the flight crew climbs into the cockpit through the forward access hatch. Inside, the atmosphere is calm but intensely focused. Checklists are opened, and every procedure is carried out step by step according to strict operational standards. The next stage is powering up the aircraft's electrical systems. As electrical power comes online, cockpit displays illuminate one after another. Navigation equipment, radar, communication systems, flight computers, and onboard sensors begin their self-checks, while the crew carefully monitors every indication to ensure the aircraft is functioning correctly. One of the most fascinating moments in the entire preparation process is the engine start sequence. The B-52 is powered by 8 turbofan engines mounted beneath its wings in 4 twin-engine pods. Rather than being started simultaneously, the engines are brought online in a carefully planned sequence to maintain system stability and allow every parameter to be closely monitored. As the first engine comes to life, a deep mechanical hum gradually builds in intensity. Compressor speed increases, fuel begins flowing into the engine, and temperature readings are continuously monitored. Once every indicator confirms normal operation, the same process is repeated until all 8 engines are running. With every engine online, the unmistakable sound of the B-52 fills the air across the flight line. The thunderous roar is not only a product of enormous power, it also signals that the aircraft is entering the next stage of mission preparation. Vibrations from the engines can be felt hundreds of meters away. Outside the aircraft, maintenance crews continue observing each engine. They watch carefully for fuel leaks, abnormal smoke, or any mechanical irregularities. Communication between ground crews and the flight crew takes place through radios and standardized hand signals, ensuring every step proceeds safely. Once all engines reach normal operating conditions, the pilots begin testing the aircraft's flight controls. The elevators, rudder, and ailerons are moved through their full range of motion to verify that the hydraulic systems respond correctly before the aircraft begins taxiing. The next phase is taxiing toward the runway. Slowly, the massive bomber rolls away from its parking position. Throughout the movement, the crew continuously monitors engine performance, hydraulic pressure, braking systems, and other critical flight indicators. Every parameter must remain within acceptable limits. The B-52 is designed to perform long-range missions lasting many hours and can remain airborne even longer through aerial refueling. For this reason, every step before takeoff follows rigorous safety standards. Even a minor issue discovered during preparation can affect the success of the entire mission. One of the B-52's greatest strengths is its combination of exceptional range, heavy payload capacity, and operational flexibility. The aircraft is capable of carrying a wide variety of weapons depending on mission requirements, from conventional bombs to long-range cruise missiles. These capabilities continue to make it an important component of the United States' strategic deterrence posture. Although its original design dates back to the mid-20th century, the B-52 has undergone continuous upgrades. Modern digital avionics, advanced communications equipment, improved radar systems, and ongoing engine replacement programs are all part of efforts to keep the aircraft operational for decades to come. The B-52's continued service is a testament not only to the strength of its original design, but also to its ability to evolve with changing technology. Even in an era of stealth bombers and next-generation aircraft, the Stratofortress continues to fulfill missions that demand long-range, endurance, and exceptional payload capacity. For maintenance crews, starting all 8 engines is far more than a routine procedure. It represents the successful coordination of multiple teams whose specialized training ensures the aircraft is ready to fly safely and effectively. For the flight crew, every indication displayed on the instrument panel serves as the basis for critical operational decisions. If even the smallest anomaly appears, procedures require further evaluation before the mission can continue. This disciplined approach reflects the military's commitment to flight safety. The thunderous roar of the B-52's engines may be its most recognizable characteristic, but behind that sound lies an intricate system of procedures, discipline, and teamwork. Every stage is carefully executed to ensure the aircraft is fully prepared for its mission. As the B-52 accelerates down the runway and prepares for takeoff, what stands before us is more than just a massive bomber powered by 8 engines. It is the product of decades of engineering innovation, operational experience, and the dedication of thousands of personnel who continue to keep one of the world's most iconic strategic bombers ready whenever duty calls.